Hi, this is Mr. Manley. We're going to take a look at some properties of logarithms here and then a couple of applications. This first property of logarithms is the change of base property here. Change of base, and you can look at that and see that if you have a log to a base, log base a of b in this case, you can rewrite it as the log of the argument over the log of the base. And let's get that those couple of terms out of the way here. Maybe using those, where this is the base and this is the argument, the value that we are taking the log of. So if you look at my iterations of the change of base formula, you see the first one here is base 10, and hopefully you understand that at this point, that this is an understood base 10 that we don't write. And then the next one, we've got base 2, and in the next one we've got base e. Again, we don't write that e. This would be log base e, right? But we don't write it like that. We write it as ln, the natural log. So you see that the change of base formula, you can change the base to whatever you want and write the log of the argument over the log of the original base. Next property that I'll take a look at is this product property here. And the product property is going to say that if I've got the log of a product, a times b, I can write it as the log of a times the log of b. Simple enough. Now, what I've got here, the next one here, log of a plus b, I hope that you're looking at that and saying, that's not right. We can't do that. And what I reiterate with students often and often and often is that log is not a number. It is not a variable. And what is a variable? A variable is a number that we don't know yet. So if I were, what I'm trying to do here, or what students try to do, is they try to use the distributive property with log, which doesn't make sense because log is not a number. Log is an operation. So we can't distribute it. This is not true. So be careful that you may find situations, encounter situations where it certainly would be convenient if that were true, but it's not. And then down here at the bottom, we've got the quotient property of logarithms. And you can see that log a over b is equal to log a minus log b. And then finally, here we have the power property on the right side here. The power property of logarithms, which allows the exponent of an argument to become the coefficient of the log expression. So we'll take a look at several, just a couple of problems that will require several of these properties. Now, one of two things is going to happen when you're working with these properties of logarithms in a math text exercise book. You're going to either be expanding or condensing. So this expression we are going to expand. This expression we would be condensing. So going back to expanding this, we are going to apply first the quotient property, which is the log of the numerator minus the log of the denominator. We're going to take a brief aside here to rewrite the radical in exponential form. So radical x plus 5 is x plus 5 to the... And then for both of these terms, we can apply the power property. And finally, we can distribute the log here. I hope that you're catching this. Can't do that, right? And if you didn't know that, you haven't been paying attention. We cannot distribute log. Just wanted to remind you one more time. And so that's it. We'll stop here. And that's an expansion. The other type of exercise is to condense. So we want to get down to get this to an expression of a single logarithm. So I want to be able to state this as ln of some expression. That's what we're going for here. So we're going to go ahead and distribute the 1/2. Actually, let's not do that yet, because I'm seeing something here that I'd prefer to do first. We're going to use this power property here and here. And then this 1, that's a little interesting, because we've got an ln, and then we've got a 1, and we're trying to condense everything down to an ln expression. So this is a pretty clever little fix for this, that 1 is equal to ln e. So just stop and think about that for a minute, or half a minute. 1 is equal to ln e. And that conversion is going to help us convert this to an expression of a single logarithm. All right, so let's continue from there with ln of x squared over y to the 4th, and then times the e. So this was subtraction, which resulted in this division, and then this addition, which resulted in this multiplication. Of course, this would be entirely different if I had the parentheses here. But as it is, we just take it left to right and go subtraction is division and then multiply. Okay. Now we can, let's go ahead and deal with this 1/2 on the outside. So I've got ln x squared e over y to the 4th, and that argument is going to be raised to the 1/2 using the power property of logarithms. And there we've accomplished our objective. We've written it as a single expression, as we were trying to do. So we're either condensing to a single expression, or we are expanding the single expression to multiple terms. And that's the types of exercises that you'll see in a math text with these properties.